Hello and welcome to iitians Gate classes once again. Myself Vivek Sharma. I passed out from IIT Kharagpur. I did my MTech from computer science and I scored 9.26 CGPA. So I have a pretty good idea about basic fundamentals of computer science and other fields of computer science. So I'll be taking data structure in this course and the relevant programming related to data structure. Programming is a very vast field. Okay, you can pick any language of the programming and many other things. So it's a evolving field, right? But we are going to cover the programming related to very fundamental programming related to data structures. So this will be our course in programming data structure, pointer and array. So if you don't know pointers, you will never know how array works. Okay, because the whole array concept starts from pointer. Then we will cover stack, queues, linked list entries, binary search tree, graph, everything covered in programming or data structure is you can say the pointer is very integral part of it. Okay, without pointer you cannot construct linked list or you cannot construct a tree like structure. Okay, these are data structure. First of all, what is a data structure? The first question is, what is a data structure? Okay, what is it? Why are we covering this? What is a data structure? Data structure. So in computer, whenever you do some programming or whenever you try to save something, it has to be stored in some manner. Okay, stored in some manner. Store in some manner or some space. So in computer, whenever you try to save something, okay, like whether it's a list of data, for example, your name, you can say VIVEK. I want to save my name in my computer. Okay, so how does it going to store? How a computer is going to understand that? How it's going to retrieve it? So data structure are nothing but a way of storing data. Okay, plus operations on that data. Operations. Data structure is not only a way of storing it. Also, we need to do some operation. If I want to modify, I want to append something like my surname. I want to append something, my surname here. How am I going to do that? Okay, or I want to delete it. I want to retrieve it. Like for example, I associate with a name. So I want to fetch it. I want to fetch my name. So all the operations also like fetching, deleting, inserting. Okay, all the operations associated to this data will also be defined by data structures only. Okay, so data structure is nothing but, if you can say data structure, it's a way to store data. I'm just saying in a very layman language so that you understand it. You can check the definition. The definition is like storing the data in specific way and also associating operation to it. Okay, a way to store data plus defining set of operation on it. Set of operations. Okay, you can say operation. Set of operations on that data. For example, let's talk about stack. Stack is a data structure, right? Stack is a data structure. I'm not going to explain the whole stack now, just to clear the definition of data structure, why data structures come into the picture, right? So what happens? Stack, if you have seen the stack of plates at any party, you can see that there is a place where we store all the plates, okay, like this. Okay, let's number those plates, something like 1, 2, 3, 4, 5, 6. Now you can see that generally people always pick the first plate. Okay, sixth plate will be picked. Now, if I want to like put some more plates, I won't be putting it here. Okay, I won't be appending here. I will again put the plate here only at this position. So this is called top of the stack. And I will be inserting or deleting from top only. These operations are called push and pop. So generally stack have two operations, push and pop. Sometimes we also define top, which gives us the topmost data item. Plate, you can consider these plates as data item. So this top will give us the topmost data item without popping it. Okay. So if you pop this item like 6, the value you will have is 6, and it will be deleted from here. Now once you insert 7, the 7 will be inserted here only. Okay, the 7 will be inserted here only. This 6 will be deleted. Now the stack will look like this: 1, 2, 3, 4, 5, and 7. Because we deleted 7. If you want to delete something, always the topmost item will be deleted. 7th. You can't directly delete second one. You can't directly delete this one. Okay. So this is the definition of stack. How do you get the definition of stack? By defining these operations, push and pop. Okay. So this is how you remember data structure. Data structure is nothing but a way of storing data. Now, what is my way? Like I am storing it something like a stack. Like I'm stacking something. And whenever I am trying to get something, I will get it from my top. And when I'm trying to put something, I will put it on top only. Okay. So this is my way. And the operations also defines data structure. Data structure are nothing but a way of storing data, and operations that are allowed to perform on that data structure is the data structure. Okay. Right. So it's like a data structure is like this only. Okay. So that's the definition. Now let's start with the course, and we are starting with pointers. It's a very important topic. If you don't understand pointer, you cannot understand any programming language like in depth, right? The first programming language, popular programming language introduced, like it's C, C++. Right now, every computer driver, computer OS, drivers, any kind of software that deals with hardware directly, okay, is include these kind of programming language, C, C++, and that include pointers. Okay. First, we will define what a pointer is. Then we will see the use of pointers in a data structure, that is an array. Okay, we define array and we will see that how array works actually, why array is required, why array existed, why do we use array so frequently. Okay, with the help of pointer. If you try to understand array without pointer, it looks very niche or very simple, very easy to learn, but that's not the way. Array don't exist without pointer. Okay, let's start pointer topic. Let me clean this slate only. So let's consider a variable of type integer. Okay, if you remember math, there are several types. Okay, in maths, integer, whole number, complex number. So let's consider integer, which is written like int a. So in C language, generally whatever reference I will give C language reference. Okay, because most of the interview, very fundamental interview, asks you the programming language to write in C language. Everywhere, right? And these days, Python and Java are also allowed. But whenever they ask you the programming concepts in interview also, they will call you and they will ask you questions related to data structure and programming, and they want you to write in C only. Okay, so this is the way I define a variable A and I assign a value in variable 10. Okay, semicolon after that. So this is how I define a variable A equal to 10. But at the back in my PC, what's going to happen? Okay, it's going to allocate a space, whatever space a integer takes. Integer takes a specific space in my computer memory, right? Your computer has some memory, for example, 1 terabyte, or you can say 10 terabyte, depends on your PC configuration. Sometimes it's 152 gigabytes, something like this, right? These days, these are the general configurations of computer. So whenever I define this, how much space it will take in the old computer, it generally takes like 2 bytes, okay, only 2 bytes. So it will take some 2 bytes of space, and that space have some address to it. Let's note that address has 1000. Let's consider that address is 1000. We don't know the address yet, right? But let's consider that address is 1000. That contains a value 10, and we label this space edge as A. Okay, so this space name is A. Whenever we say like print %d A, okay, whenever I say print %d A, it will check that, okay, this A I am referring to. So what is its address? It's 1000. And what I'm going to store, what I have stored to 1000, it's 10. So it will print 10, right? So what it will do, again, let me repeat, it will create a space of 2 bytes. Okay, sorry. Okay, I mistakenly erased everything. Yeah. It created a space of 1000 or 2 bytes, which is starting with 1000. This is the address of variable A. The name of the variable is A. Okay, I'm writing it here, and it contains value 10. Okay, so what if you want to have this address? I want to print this address instead of printing the value. What I will print, I will say that, okay, print %d or some percent, I don't know, like how to print the address. You will give some command here, and then you will say that and %a, and %, this is the sign, and %a. Okay, and %a will give you address of A. Okay, so our PC have some space, and each memory unit have some address to it. We allocate that address, and we say that, okay, this is your house. You can put the value here, and the address of your house is this, and the short name of that address is this. While your program is running, you can refer using A. And if you want to get the address of it, you will write and %a, okay, instead of A. That's it. Okay. If you clear about this, that whenever I write int A equal to 10, what does it mean? It means, let me repeat one more time. It creates a space of 2 bytes, and its starting address, not the whole address. The starting address is 1000. Okay. And see, in computer organization, CO, you will learn that how these addresses are actually works. Is it byte addressable? Okay, sometimes it's not byte addressable. We assign like, okay, my single address unit is actually 2 bytes. 2 bytes. In that case, this address is sufficient. If I say that it's byte addressable, means each byte have an address. So actually, in actual, if I'm saying that each byte have an address, and I'm considering that the compiler is allocating an integer into 2 bytes. 2 bytes. Okay. Then in that case, this A will actually take two addresses, 1000 and 1001. If it's starting with 1000, it will take actually 2 bytes, 1000 and 1001. There I will store 10 and I label it as A. Don't get confused. I'm saying that if our compiler is actually allocating 2 bytes for a data type integer, okay, then in that case, it will store like this. In most of the compilers or programming language, you can say, like generally this character, char, for example, instead of defining an integer, if I define a character, how can I define a character? I can define it like char in C programming, char, like ch equal to, for example, A. Okay, not A, it will confuse you. Let's write something, some letter here. I'm saying that this character is actually some S character, okay? So this is I defined. At the background, how it will store it? Generally, the character take 1 byte only. Okay, so it will store like at some 2000 location. It will store this S and it label it as CH. Okay, this is how I'm going to store it in my computer. Why it don't have two addresses? Because it only takes 1 byte, not 2 bytes. If it takes 2 bytes, it will take two addresses, 1000 and 1001. Okay, but right now we are only indicating the starting address. Okay, so for now, we will consider only starting address. Okay, so whenever you do %A, like, okay, let me go to the next page. Whenever you do %A, what it will give you? If you print like printf %A, in short, I'm writing as printf here, like %A, it will give you 1000. Okay, if my A is storing like at 1000 and 1001, 10A, then it will give me this address, the starting address, not the both of the address. It will give me starting address. Okay, if you see here, this character is stored at it's taking 1 byte and it's getting stored at 2000 location. So if I print and %ch, it will print on the console 2000. Okay, the starting address. However, this character is taking only 1 byte, and that is the only address it have. But if you see at this integer variable A, it's actually taking two addresses, 1 and 2, right? Two addresses, but it's only printing the starting address. Okay, remember this. It will be helpful in array also. That we only print starting address whenever we print the address, only the starting address. Okay, now I want to store. Okay, let me write. Whenever I write the program, I will try to write it in red color, so you won't get like this whole thing should not get mixed up. Okay, so if I write like int A equal to 10, now I want to store the address of A, not only print. I want to store it. How can I store it? I can store it like int star B. The star is indicating that I am going to store the byte address of which type? Integer type. The byte address of integer type. Okay, how can I store it? And %A. So in this B, you cannot simply assign like star. You cannot simply say that int star B equal to 10. You cannot do, because whenever we say that int star B, it means that there will be some address going to come and store in B. Okay, so whenever you print B, if you see you print B, what it will print? It will print the address of A, which is what? 1000. If you print B, it's equivalent to printing and %A. It's equivalent to printing and %A. But the star indicates that it's a address of type integer type address, okay, integer type address. And this is called a pointer. This is a pointer. So what is a pointer? A pointer is nothing but you can say a variable. In terms of programming language, I'm saying it's a variable storing the address of some location, of address of some variable or some location. That is called a pointer. That is a pointer. Okay, I hope this is clear. This is how you can store the address. And a variable pointing out to a address is called pointer because it's pointing to a address. Okay. What if I want to print using B? I want to print the value of A. So we already know that B is containing address of A. Okay. So here we know that if we write star B, it means that B contains address of A. Address of A. Okay. B contains address of A. Right. And if we print B, it will give us address of A. What if we want to print the value of A, the value of A, not address, the value, which is 10, right? So what we can do, we can print it like star B. The star B indicates that, okay, go to address, which we stored in B, go to, not B's address, go to the address which we have stored in B, variable B, okay, and print its value, okay. So let me write in terms of like this, or A have 10 value, its address is 1000, and this is our B. B actually contains this address, which is 1000. Okay, and suppose we are storing it at some location 10,000, or you can say 5,000. Okay, 5,000. B will also have some address, right? Obviously, even if it's pointing to something, we are storing it in the. If we are saying that star B equal to n%A, okay, int star B equal to n%A, it means that we have to store B also somewhere. So B is also stored here. So it's storing like this. We have done int A equal to 10. This is what we have done. This is how it looks in memory. Okay. Just for the sake of like simplicity, I have taken the sample address as 1000 and 5000. It may be different based on your compiler and the location. Okay, so this is how we are storing. At 1000 location, we have a value 10. Okay, and at 5000 location, we have a value 1000. So once we do star B, it will go to this location and pick its value, which is 10. So if we do print star B, what it will print? It will print 10. Okay, let's move on to some more complex examples. I will try to cover as much example as much possible, as many example as much possible, as many possible. Okay, yeah. So let's clear the board and let's try to write a simple example. So you can find out like some example like this in your programming tests or interviews, and you have to give the answer for it. Void f int star p int star q. So you have two integer pointers. Okay, the star is saying that these are integer pointers. Okay, and what do? You say that, okay, p equal to q. At star p, I will store 2. Okay, this is what I will do. in this function. Okay, and I will call this function f. How I'm going to call it? I'll say that, okay, initialize int I to 0 and int j to 1, and call this function f and %i and %j. Why do I have to pass and %i and %a and not ij? Because here, whenever I am going to call function f, I have to pass integer pointers. So these are integer pointers, and %i and %j. Okay, these are integer pointers. So that's why I have to pass it like this. And I do some print function will be there. I'll print I and j. What it will print? Once I call this function, after this function, I and j will have some value. Okay, so let's try to solve it here using some other color. Initially, after this statement, we have a variable I, and it have value 0. We have a variable j, it have value 1 initially. Okay, initially. And this is stored at location 1000, let's assume, and this is stored at location 2000. Let's assume that, okay, the starting location is 1000, 2000. Then we call this function. What does it mean by calling this function? We are passing the address of I and address of j, and %i means address of I and %j means address of j. So we are actually calling 1000 and 2000. Okay, these are address of 1000 and 2000. These are address of, this is the meaning and %i, this is the meaning of and %j. Okay, it's clear till here, right? Then once we call this function, we assign it to some variable p and q, right? P and q. So what will the value of p? P will have 1000, q will have 2000, and we can give them random address. We are not going to use them, but still let's give them some address like 10,000 and 20,000. Okay, P and Q also have some address. Till now it's clear, right? Once we pass these addresses, once we call this function f, we pass these addresses to P and Q, right? So this star P indicates that this is a integer pointer, int star P. Int star Q says that it's a integer pointer Q, and address of I will be stored in P, address of J will be stored in Q. As you can see, the address of I is 1000, so P have 1000 value. Address of J have 2000 value, so Q have 2000 value. Okay, rest we will solve here. Now, after that, this statement executes. It says that P equal to Q. Okay, so we are assigning the value of Q in P. So initially, before this statement, P have 1000 value, Q have some 2000 value. Okay, this is the address of J and %J. You can say this is the address of I and %I. Okay, and %I and %J. So then we are saying that, okay, P equal to Q. What does it mean? That we remove the value of P and we assign the value of Q, which is 2000 here. So after this, P will have 2000 and Q will also have 2000. Then we say that star P equal to 2. Star P means whichever address P have, go to the address and change its value. Star P equal to 2. Okay, P have 2000 address, so it will go to 2000 address, okay, which is J, and it will change its value to 2. Okay, so then this function will end and it will print ij. So what will be the value of ij? I is equal to 0 now, j is equal to 2 now, so it will print 0, 2. Okay, so this is our answer. 0, 2 is our answer. Okay. So I am going to write this function again, and you can write down the answer, and you can go back to the previous step and try to write it again. Like, okay, it's void f int star I, int star p, int star q. It means that they will contain some integer pointers. Okay. Then we say that p equal to q and star p equal to 2. Okay. And how did we call this function? We initialize two variables, int I equal to 0, int j equal to, okay, int j equal to 1. Then we call the function f by passing address of I and address of j. Okay. Then we print pf, print means pf means print. Okay, we print I and j. So what this print, this will actually print? This will actually print 0 and 2, 0, 2. I explained in previous slide how it will print 2. Okay. So let's move on to the next example here. Next example is going to be a bit complex. So watch carefully. So we are saying that we have a function f. We have a function f which have int x, int a py pointer, a pointer, star means a pointer, py pointer, and a pointer int which I denote as star and star ppz, pointer to pointer. pp means like I'm indicating this pp as pointer to pointer. So what does it mean by integer int star star? It means it contains address of a pointer, not only the address of a integer value, it will contain address of an integer pointer, pointer to pointer. Okay, pointer to pointer. Now what this function will do, it will say that, okay, int, let's initialize two variables. Let's create two variables y and z. Then what we will do, we will go to the pointer to pointer ppz plus equal 1. It means that whichever pointer to pointer we have will go to its value, pointer to pointer ppz plus equal 1. Okay. Then we will assign z equal to star ppz. Okay, ppz. We assign its value. We increase the value by 1. Then we will assign the value to z. Then we'll do star py plus equal 2 plus equal 2. Okay. Then we say that, okay, y equal to star py x plus equal 3. Then we will return x plus y plus z. Okay, we'll return this. Then we call this function. Okay, we call this function. Like this. We will call this function like this. We assign a variable integer c. We create a integer c variable. We create a, you can say, okay. We create a variable and assign as well as c equal to 4. We create a, you can say, pointer to this c as and a %c star b. Okay, integer star b. So we have to write it like this: integer star b int star b equal to and a %c. Then we create one more pointer to pointer, which will basically contain b star star, pointer to pointer. Okay, star something D, which will have the value of and %B, address of B. Okay, B will have address of C and D will have address of B. Then we print F of C, B, D. So we are basically calling this function F. We are passing C here in X, B here in PY, D here in PPZ. Okay. Then this function will execute. Whatever it will return, X plus Y plus Z, will be saved here. Okay. X plus Y plus Z will be printed here. So what will be the value? Let's solve this. First, note this down. Okay, note this down. Pause the video, note this down. So I'm solving it here. It will be a bit messy. Okay, and you can go step by step. So here we have created a variable C, which contains a value 4. Okay, so we are creating a variable C, which contains a value 4. And it has some address 1000. We have created a value B. Okay, it contains some value. It contains and %C. It means address of C, 1000. And we have some address 2000. Then we created a variable D. Okay. It contains the address of B, which is 2000. Okay. And D also has some address like 4000. So till here we are clear, right? Till here we are clear. Then we pass this CBD in this. Okay. So once we pass the CBD here, X will contain actually the value of C. Whatever we pass here, it will contain in X. So X is a different variable. It's not C. It's not C actually. Whatever value C contains, it's passed to X. So we create a X at 5000 location, and it contains 4. PY have some address. So we create a variable PY. It has some address, something like you can say 6000. And it contains address to PY will contain address to PY will contain value of B. What is B? It's 1000. Okay, it's 1000. PPZ contains the value. It will be stored. It's a different variable. Okay, PY is a different variable. PPZ is a different variable. So we are creating different variables here. Okay, we are creating these 3 different variables. PPZ. PPZ have some value. What's the value of PPZ? It is basically equal to D. D have 2000. Okay. And it's stored at, for example, at 8000 location. Clear? Then what we are doing? We are doing this operation. We are saying that star PPZ plus equal 1. Star PPZ. Okay. Star PPZ means go to location 2000. Okay. Then go to location 1000. Okay. We are here. Increase it by 1. Let's use some other class. So we increase it by 1, which is 5. First step is clear. Okay. Star PPZ means go to its location 2000. Okay. Go to 1000. Okay. And increase its value by 1. Then it's saying that assign Z to star PPZ. Star PPZ is 5. So we assign Z. We will create a variable Z. Okay. Z. And here Z will have value star PPZ. So what is star PPZ? It's 5. Z will have 5. Okay. Then here it says that star PY plus equal to star PY. Star PY means 1000. This is star PY plus equal to. It says okay 7. Now it says that create a variable. We already created a variable Y. y equal to star py. Star py is this, which is 7. So it create a variable y, assign a value 7 to it. X plus equal 3. X plus equal 3. So we will do x plus equal 3, which is 7 here. Now do x plus y plus z, which is 7 plus 5 plus 7. 7 plus 5 plus 7. 14 plus 5, which is 19. Okay, so this will be 19. And we will print 19. So 19 is the answer. Okay, so this is how it's going to happen. Let me repeat it again in like a bit clear manner. You can take this code as a reference. I'm repeating the step one by one. Okay, on the like clean page. Initially, we have 3 variables, C, which contains value 4. We assigned C as 4, okay, and it has some address 1000. We assume that it's at address 1000. Then we created a B, which is a pointing out to C location. So B contains 1000, the address of C, and it's stored at 2000. Okay. Then we have again one variable D, which is pointer to pointer. It means it contains address of a variable which contains address. Okay, so it contains address of B 2000. And we stored it at some location 4000. So that's what it says till here. Till here, that's what it says. Now we pass C, B, D to new variables of function X, Py, and ppz. Okay, these 3 are new variables: X, Py, and ppz. X is a simple integer which contains value 4, and we assumed that it's at location 5000. ppy contains value of B, which is 1000. ppz contains value of D. This is not B, this is D. Value of D, which is 2000. Okay, till here it's clear. And we assume that it's at location 6000, 5, 6, and 8000. Okay, 5, 6, and 8000. It's clear till here, right? Till the function call is clear. Now we created 2 variables, y and z. Y and z. We created these 2 variables. Initially, there is nothing in it. Now we say that star ppz plus equal 1. Star ppz plus equal 1. Star ppz. Star ppz means 2000. Go to 2000. Okay, we are here. Then again star, it means 1000. We go here. Plus equal 1. So we increase its value by 1, which is 5. Okay. Then we say that z equal to star ppz. Whatever value star ppz have, star ppz means star means 2000. Let's go to 2000. Then again star, it means go to 1000 here. Whatever value it have, assign it to z. Okay, we assign it 5. Then we say that okay, star py plus equal to star py. Py have value 1000. Go to 1000. Go to 1000 here. Then increase its value by 2. Okay, 5 will be increased by 2, 7. Then assigned y to star py. Y to star py. Star py is 7, 7. In next step, we increase the value of x by 3. Okay, we increase the value of x by 3. Then we do x plus y plus z, which is 7 plus 7 plus 5, which is 19. Okay, 19. So 19 is the answer. Whenever you try to solve this program like this, assign very simple addresses like this. So you can store this address in variables like this, and you can basically refer back and go back and increase, decrease the values. Okay, let's solve some more examples. Oh, sorry for the disturbance. Let's solve some more examples here. Then we will move to the array pointers. Okay, so there is a doubt here that some people might have, that whenever we do in C programming scanf, we generally provide send B, something like this. Okay, we generally provide %a. We don't write a here because we want to store the value at address of A, right? So if you do int a, then %a, it means that we allocated some address to A, like this, A equal to 1000. And %a, it means that we want to enter some value. We want to we want user to enter some values, and it will go to this address 1000. And %a means 1000, right? So it will go to this address. That's what it means. Okay. Now let's move on to the next example, which is an array. So let's consider an array int a equal to 12, 7, 13, 4, 11, 6. Now, the fundamental of array says that array will always be stored in sequential manner in the memory also. Okay, so how this array will be stored? If we consider that each integer takes 2 bytes, okay, let's consider from the beginning. So later on, it won't create confusion to you. Okay, so let's try to write it like this. It will be stored in memory like this. I have to take bigger value. At 1000, we will have 12. At 1000, we will have 12. Then at 1002, why 1002? Because 1000 and 1001, both address will point out, both will be consumed by 12, because integer in generally in every programming language, integer takes 2 bytes. 2 bytes. Okay. So the first byte, for example, it will be saved like this. First byte will be saved here. Second byte will be saved here. So the 12, and you can it's 16 byte. The first 2 bytes means 16 bit. 1 byte equal to 8 bit. 2 bytes equal to 16 bit. So once we represent 12, it is basically 8 plus 4. So it will be indicated as 0, 0, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay. So these 8, 4, and 4. So it will be saved like this. So there are 2 processes, big endian and small endian. I will be covering later on. Let's consider this manner. So the first byte, 0, 0, 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, 0, 0, 0, 1, 1, 0, 0. So this is 12 actually. This is 12. So we represent 12 in bits, in 16 bit actually, 16 bit. And this is the address location 1000, and this is the address location 1001. So whenever we say where is 12 stored, where is this variable 12 is stored, we say that it's stored at 1000 location. And we are saying that it will take 2 bytes. It means that 1000 and 1001. So that's why we directly jump on to the next number, which is 7. So 7 will be saved here. 1004, 13, 1006, 4, 1008, 11, and 1010. Okay. I hope it's clear. Like we can represent 12 in bits, like this 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 0, 0. Okay, in 16 bits. Then these 16 bits can be splitted into 8 bits. And first 8 bits can be stored at 1000 location, and second 8 bits can be stored at 1001 location. This is not exactly right, because sometimes these are stored at 1000 location, these are stored at 1001 location. It depends upon your compiler. So there are 2 approaches, big endian and little endian. Okay, I will cover this in programming course where I explain typecasting. Okay, I will cover that later. For now, you can consider that 12 is stored at 1000 and 1001. So I will only represent it using first address, or you can say starting address, right? So I represent 12 as 1000. Then 1000 and 1001 are consumed by 12. So the next address is 1002. 7 will be stored at 1002. It's clear that that's how the array will be stored, right? So once in array, I do like A0. Generally, if you have done some kind of coding, if you want to fetch the first address, the first number 12, you do like A0. This A0 is actually will be converted into A plus 0 star, right? Here, this is the index. This index this is the index, and this A represent starting address of the array. Okay, starting address of the array. This A represents starting address of the array. So what is A? A is actually equal to, I don't have to print %A here. It's not int A, it's actually int array. Okay, int A array. So this A is actually, if we consider this mapping of the addresses, A is actually 1000. A is actually 1000. So once I do A0, what it will do? It will do A plus 0 star, and it will be 1000 plus 0 star, which is equal to 1000 star. So 1000 is the address location, star is the value of that address. So that will be 12. Okay, you can see here 1000 is the address of 12. So it will print 12. It will print 12. Okay. So what if I do A2? It will do, this is complicated. Okay. Try to understand A2 and you will understand the operation, how indexes are shifted in the array. It will do 1000 plus 2 star. Now look at this. We know that each integer is taking 2 bytes, and this is a integer array. This is a integer array. So 1000 plus 2 won't be equal to 1002. 1000 plus 2 is actually equal to 1004. Why? Because once we do A plus 1, sorry, A plus 0 is actually 1000. A plus 1 is actually 1002. A plus 1 means move to the next element, not to the next address. Move to the next element address, and not to next, not to increase by 2. It doesn't mean increase by 1. It doesn't mean increase by 1. Remember this. Sometimes these kind of question has been asked in interviews and programming rounds and at many places. So A plus 1, it means move to the next element address. Okay. Doesn't mean increase the value by 1. Okay, it doesn't mean you are increasing the value by 1. You are saying that move to the next element. And where is the next element address? What is the next element address? Next element address is 2 steps ahead. Like, because each integer is taking 2 bytes, the next element address is not at 1001. It's at 1002. Okay, it's at 1002. So a plus 1 means 1002. A plus 2 means 1004. A plus 3 means 1006. A plus 4 means 1008. Okay. So once I do A3, what it will do? It will do A plus 3 star. A plus 3. What is A plus 3? 1006 star. What is 1006 star? 1006 star is this. 4. Okay, so 4 will be printed here. So that is how you can index an array. So if an array is given, something like int array is given, like 12, what was the array we considered? 12, 7, 13, 4, 11, and 6. It will be stored like this. We can give some temporary address. Like we are assuming that its address is 1000, it's 1002, because generally programming language takes for each element of integer type takes 2 bytes. 1004, 1006, 1008, and 1010. Okay, and if we give indexes, it's 0, 1, 2, 3, 4, 5. And if I want to get this element, I will do A4 and it will give me 11. A4 is equal to 11. How it's 11? It's actually A plus 4 star. A4 means A plus 4 star. Okay. What is A plus 4? I gave you here. What is A plus 4? A plus 4 is 1008. So it's 1008 star. Go to 1008 location, try using star, it means we are going to print its value. So it's 11. So this is how we actually use array. If array is sequential, array will always be sequential. Then only we can apply these operations. How much time it will take? Order of 1. Because there are only, you can say, two operations of unit time. We are taking only 2 operations. We are doing this summation. Okay. This is how array works. So once you understand the pointer, you know that how pointers are increases. Whenever I do, A is a pointer. A itself is the address. What is A? 1000. Whenever I try to print A, it will give me this address. What if I do star A? It will give me 12. Okay, 12. Star A is actually equal to A0, which is basically A plus 0 star. Okay. I hope till here it's clear. Now let's move on to a very small example. For example, if we take 2D array, 2-dimensional array, okay, where we say that A of ij, okay, for example, you can say A of 2, 4. What does it mean? It means that second column, second row, fourth column. Let me try to write it something like this. So generally we try to, we generally print arrays like this, right? 2D array. We imagine like this, okay? This is 0, 1, 2, 3, 4, 5, 6. These are columns, 0, 1, 2, 3, 4. These are rows. Okay, we always try to print it like this. It's easy to understand. That's why we enter it like this. Right? Now, if we do A24, what does it mean? It means that it will do A plus 2 star plus J star. J means 4 here, 4. Okay. 4. Okay, let me try to write some values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 4, 5, 6, 7, 8, 9, 10, okay, 28, 38, 28, 29, 29, 30, 31, 32, 33, 34, and 35. And what do we want here? Using A24. A24 means 2 and 4. This is what we want. This is what we want. How can we get this? How can we get this? Okay. It will say that, okay, if the initial address A is 1000, we are starting from this location. Okay, this is 1000, and it will go like 1002. This is the address 1002, 1003, 1004, 1005, 1006, 8. Okay, it will go like this. So it will do 1000 plus 2, right? It's basically 1004. Now 1000 plus 2 is not equal to 1002. We already discussed this. It will jump 2 addresses, 2 elements. It will not generally add 2. It means 1004. Okay. It will go to this column. It will go to this row. Okay, I mistakenly entered this. Actually, A24 means this element. This element. A24 means actually this element. So let's take a smaller example. This will actually confuse you. So let's take a smaller example with some addresses also. So I will try to enter the addresses also here. So in green, let me write the address. So this is 1000. This is 1002, 1004, 1006. Then we have 1008, 1000. We have 1010, 1012, 1014, 1016, 18, 20, and 22. 2, 4, 6, 8, 10, 12, 13, 10, 12, 14, 16, 18, 20, 22. Okay, this is what we have. Let me give indexes to the columns. It's 0, 1, 2, 3, and rows 0, 1, 2. Okay, so and the values also. So we have value like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, if I say A22, let's say A23, okay. So it's the second row, third column, second row, third column. What is it? Second row, third column, second row, third column. This is it. This is what I want. This is what I want, okay. So it means that first I will do this operation. This is basically A plus 2 star. Then I will do this operation. I will do plus 3 and star. This is how 2D matrices address will be calculated. Address and value. So this will give us the address, and this will give us the star will give us the value. Okay. Yeah. So let's go back and try this. Okay. So what is A plus 2? A, we know that it's 1000. A plus 2 means we are jumping 2 rows. Here this A is 1000, right? It's 1000, but A plus 2 means we are jumping 2 rows. So what is address? It's 1026, 1016. Then we go to 1016, and we will do +3, right? So +3 means this address. So this 2D may confuse you, but actually, if you try to understand it, here in case of 2D, a plus 1 means this row, first row. A plus 2 means second row. A plus 0 means zeroth row. Okay. Here, this A is actually pointer to pointer. First pointer is pointing out to zeroth row. This pointer to pointer, this address, wherever this address is stored, 1000 is stored, right? It's pointer to pointer. It's pointing out to this row. Then this is pointing out to this row. Then this is pointing out to this row. Okay. So this is A plus 0 actually. This is A plus 0. This is A plus 1. This is A plus 2. So if I do A plus 0 star, it means that I am actually fetching this whole row. Then A plus 1 means this whole row. A plus 2 means this whole row. This is how 2D array addresses are calculated. Okay, thanks all for today for joining. And in the next example, we are going to show some very good examples. Okay, of these pointers in array. Thank you all for joining.